In this video, I'll show you how to build a notification system for asteroids that could potentially hit planet Earth. This should be a fun project, so we're not going to build a fully fledged system, but I will give you some ideas on how to use NASA free APIs to build a nice portfolio project, and you could add your own expansions to it. On screen, you can see the concepts we will be covering in this video. And if you want to follow along, please install the list of software you see on screen. Let's start. Let's start by having a look at the diagram of our system. So we're going to have an asteroid alerting service, which is going to be our Springboot application that is going to do a synchronous call to a NASA API. NASA provides a specific API that returns near-Earth objects, and we're going to use that to get a list of asteroids which are potentially dangerous to Earth, and then we're going to send those as events on a Kafka topic, and eventually these messages are going to be picked up by notification service. They will be stored in a MySQL DB, and an alert will be sent to users. So this is the overall flow of what we're going to build. Let's now take a look at the API we will be using. So NASA offers different APIs for free. It's quite easy, just go on Google and type NASA APIs, and this is the page that you will be shown. If you scroll down, you can see that you can sign up and get your own API key. I suggest you do that, so just fill in your name, surname, and email, and you're going to get back an email from NASA with your own API key that you can use to send requests. There is also a demo key that we can use. This is literally the key. Demo_key is the key, but there are limits, so it's limited to 30 requests per hour and 50 daily requests. So if you're gonna be sending more than the limit, I suggest you sign up and you will get an email back with your key that you can just use. So if we scroll down furthermore, we can see that there are a lot of APIs that NASA offers, but the one we're going to be using is this one, Asteroids NeoWS. So this stands for Near Earth Object Web Service, and this is a REST API. If you scroll down, it's quite simple. It takes as input some query parameters, start date, end date, and an API key. And just note that the end date can be 7 days after the start date, and it's going to return a list of objects. There is an example query which we can use where the start date is 7th of September and end date is 8th of September. If you click on it, we can see a possible response that we are expecting to get. We have an attribute that gives us the total count, so 27 asteroids between these dates, and we have a hash map, so we've got each date mapped to a list of asteroids, and each asteroid has a bunch of attributes. As you can see, there are many, but we just need few of these, and the most important one is this one, is potentially hazardous asteroid, and if it's set to true, this is what we want to send as notification. This is an asteroid that is worth alerting our users for. As you can see, this other one is false, and we have also other parameters such as the estimated diameter in different units, and we've also got the close approach date. There are also some other important attributes such as the relative velocity and the missed distance. So I guess this missed distance is distance to Earth, and it's given in different units. So this is the expected result. Get your API key. Otherwise, you can just use this demo key for now. And if you think you need more requests, you need a higher limit, you can just go here and simply get your own API key. So if we go back to our diagram, this is what we are going to start building first. An asteroid alerting service. So this is the service that is going to trigger the whole flow, the whole alerting flow. We're going to go on Spring Initializer and create a new Springboot project. We're going to be using Java, Maven, and select the latest version of Springboot. So I'm going to use 3.4.3, and let's give it a name. So I'll call it LeetJourney, and let's give it a name. I'll call it Asteroid Alerting. Description, send notifications for NASA asteroids. We need a bunch of dependencies, so let's add Spring Web. We are going to be adding Lombok, and we need Kafka. So make sure to select Spring for Apache Kafka and not the second one. So this is all we need. Generate the project and let's open it in IntelliJ. I have opened the downloaded project in IntelliJ. The first thing we need to do is create a controller. So let's create a new package called controller and let's create a class in here. I'll call it Asteroid Alerting Controller. We want to add a bunch of annotations, so it's going to be a REST controller. And we're going to accept a request mapping, and this looks good to me. So this is the base of our API request. Next thing we want to do is create a post endpoint, so post mapping. And this is the endpoint that we're going to call to trigger the whole flow, where we're going to query the NASA API and then put events on Kafka topic. So I'll call it alert, and we want a response status, and we want to send back a HTTP status accepted. I'll call it public void alert. And what we want to do here is we want to call our service class and call a method in our service class. So we don't have the service class yet, but we'll create it in a minute. So I'll call it Asteroid Alerting Service.alert. Let's create this service class. So let's create a new package called service. And let's create this new service class called Asteroid Alerting Service. And let's go back to our controller class, and we want to inject it in here. So private final Asteroid Alerting Service, and let's auto wire it. So let's inject it in the constructor. So this is good. Let's go to our service class now, and let's concentrate on this part, which is the main logic of our system. So this is a service class, and also let's add SLF4J for logging. And let's create our public void alert method. So we want to do a bunch of things here. Let's start by logging. So in here, we now want to do a bunch of operations. So we first want to calculate from and to date. And then we want to call the NASA API to get the asteroid data. If there are any hazardous asteroids, we want to send an alert. And what I mean by alert, we want to put an event on a topic. We create an alert and put it on a Kafka topic. And that's it. That's what we want to do in here. So let's start by calculating the from and to date. It's quite easy. We can use local date. And because it's an alerting system, we want to possibly alert users on something useful. So I've decided to alert them from today up until today plus 7. So that's the maximum day anyway. We cannot query the API for more than 7 days from the starting date. We are simply going to use local date to calculate these two. So we now want to call the NASA API to get asteroids. So let's add some logging. And the next thing we want to do is call a NASA client. So we are going to build this class in a bit, and we want to get the NEO asteroids. And as input, we'll give the from and to date. We are going to create a NASA client. We don't have it, but I'll just add it for now. And we're going to inject it in the constructor of our service class. So if we go back here, let's create a new package called client. And in here, let's create our NASA client. This is a service class. Let's add the tag. And let's create a method. So this is going to return a list of asteroids. And let's give it a name, get neo asteroids. And this is going to accept a local date, from date to date. This asteroid class does not exist yet, but we'll create it in a bit. And we want to do some operations. So we're going to have a REST template that we'll use to make our endpoint calls to the NASA API. And the next thing we want is some URLs. So we need to know where to send these requests. So in our application.properties, we need to add a bunch of properties. So if you go to resources, application properties, we need to add the API URL, which you can find on the NASA NEO page, which is this one. and we want to add our API key. So for this video, I'll just use the demo key, but if you sign up, you will get your own key and you don't have limits that way. Let's go back to our client and let's import those values. I'm going to put them in a string, and the second one is the API key. Now what we can do here is we can create a response object. So I'll call it NASA Neo Response. This one does not exist either, but we'll create it in a bit. Using the REST template, we're going to call a URL and we'll get back a NASA Neo Response object. So let's create this getURL method. So it's going to be a public string getURL, and that's how it's going to look like. So we'll get as input a local date, so the from date and to date, and we're going to build the URI using the NASA Neo API URL, and we're going to add the 3 query parameters which we have seen on the documentation. So if we go back here, we can see that it accepts 3 query parameters, and this is how the request looks like. So we have our URL. The next thing we need to do is create these objects over here. So these are some data transfer objects, also called DTOs. I'll create a DTO package. What we want to do now is recreate this structure in Springboot. So we can see that this is a map. And now we need to determine the other properties that we think are important, and we're going to ignore the rest. So for example, we'll be getting the ID, the name, we will be getting the diameter in meters, I guess. Important as well, this flag here, and we want the close approach date and the missed distance as well. I think that's quite interesting to be sent in a notification. So I think this is all we need. So as I said, we need to recreate this hierarchy inside Springboot. So let's go back to IntelliJ and let's create our first DTO, which is going to be NASA Neo Response. So let's create a new class. I'll call it NASA Neo Response. And we want to add a bunch of tags using Lombok. This is going to avoid us writing a lot of boilerplate code. And in here we said that this is a map and it's a string, and then we're going to get a list of asteroids and we'll call these near Earth objects. And we need to define the JSON property. This is the name that is going to be returned as part of the JSON return data. So it's actually called near Earth objects. If you go back here, that's how the property is called. You need to make sure to get these names right. And the other thing we're going to also get is the element count, just in case we need it. So this is the number of total asteroids. The next thing we need to build is this asteroid class. Let's create another DTO called Asteroid. So let's add the same as before. Builder. No args constructor, all args constructor. And now we also want to add this other property called JSON ignore properties and ignore unknown, and let's set it to true. What we want is a private string ID. We want the ID of the asteroid. We want the name of the asteroid. We want the estimated diameter. So let's define the JSON property, which was estimated diameter. By the way, you have noticed that I've created another object for estimated diameter. If we go back here, we can see that this is not a single entry. This is actually an object within the asteroid object. So you need to define it as an object inside your asteroid class. And the other one is the private Boolean, potentially hazardous. Let's define the JSON property. And the last one we need is the close approach data. And this is again a list of close approach data. Next thing, let's create this estimated diameter. Let's go in DTO, let's create estimated diameter. Let's add the same tags. In here, what we want is the diameter range in meters, and the property is meters, meter range. So we also want to create this diameter range class. Let's create another DTO. And let's just copy and paste these properties so we don't have to rewrite them. So now here we're going to get the min diameter and the max diameter. So JSON property. What we're doing now is mapping the expected response to DTO objects. So this is good. Error is gone in here. We have to do some imports. Estimated diameter is okay. Diameter range is good. We need this close approach data. So let's create a new class, close approach data. Let's copy these tags. And in here we need two properties. So one is the date of the close approach date. And let's define the JSON property. This is the close approach date and the missed distance. So this missed distance, again, it's another object, and let's define it as such. Let's define the JSON property, and this should be the last DTO we need to create. Let's copy these properties. We want to note down the distance in kilometers. You don't need to define the property because the name is the same as the one as the return JSON payload. But let's say you want to write it the British way in your application, you then need to define the JSON property in the American way. But in this case, we don't need it. So these are all the data objects we need. Let's make sure nothing is red. So we've got everything. We need an import here. Let's go back to our client. Let's import these classes. So red is gone. Here we want to return a list of asteroids. Once we get the response, let's do some operations. Let's create a new list of asteroid, which is what we're going to return. And this is going to be an array list. And if the response is not null, let's add all the responses from NASA NEO for each date to our asteroid list. And then we're going to return our asteroid list. I'm getting all the near Earth objects, and because this is a map, we're going to get all the values, stream these values, and then create a list out of these. And then we want to add this list into the asteroid list. Once we return this, we are going to go back to our service class. We can import our NASA client. Error is gone. We are now going to get back a list of asteroids. And I'll call it asteroid list. And let's also print how many asteroids we have retrieved. So this will give us the size. Now we want to go to the next step. If there are any hazardous asteroids, we want to send an alert. So we want to create a list of dangerous asteroids. We're going to do a stream, and then we're going to filter by this property is potentially hazardous. If this is true, we'll add it to the list of asteroids that we want to send as a notification event. So this was quite simple. Now the next thing we want to do is let's add it as a log, and let's do the last step. This is where we're going to be using Kafka. We want to create a Kafka event, but before even creating the Kafka event, we actually need to be able to run Kafka on our system. So we need to create a Docker Compose file. So go to the top, let's create a new file called dockercompose.yaml. And we need to run a bunch of services. I have just copy and pasted from another configuration I created as part of another video. Simply, we're going to be using Zookeeper. So we're going to define a Zookeeper service. We are going to be defining a Kafka broker, and we have a Kafka broker ID 1. We don't really need replication. So topic replication factor, I've just set 1. Next thing, we are also going to define a Kafka UI, so we will be able to see our messages going to the topic, and we need the Kafka schema registry. So please just create these services in a Docker Compose. You can get the code on my GitHub as well. If you don't want to type them in, you can just copy and paste from my Git repository. And now let's start these services. So let's do Docker Compose -v app -d. And this is going to take some time. If this is the first time you're running this operation, this is going to run in the background in the meantime, and we'll come back to it later. So let's go back to our service class, and now we want to create a list of events we want to put on our Kafka topic. So the first thing we need to do is we're going to create a list of Asteroid collision event, and we're going to create this list of asteroid collision event using the dangerous asteroids we separated, we filtered up here. We want to create this class, so let's create a new package called event, and let's create a new class called asteroid collision event. Let's add some tags, and let's now add all the properties we want to send as part of our notification message. So I think it would be interesting to receive as a receiver of a notification of this kind is the asteroid name, the close approach date, the missed distance, and I guess also the estimated diameter. Let's send an average in meters because the one we get is a minimum and the maximum estimate. So we're just going to average it and send it as part of the notification. So let's import this class in our service class. And let's create this list of events. So this is quite simple. I don't want to spend too much time on this. It's basically using a stream. It's using functional programming. So let me just show it to you. So we are going to create a private method that is going to get a list of dangerous asteroids, and it's going to return a list of asteroid collision events. So we'll do a stream. If the asteroid is potentially dangerous, we want to create a collision event using the properties for the asteroid name. We'll get it from the asteroid class. Close approach date, you need to go to the approach data class, get the first one and get the date. Same with the kilometers. This is quite simple. I don't think I need to spend much time on this because this is simple Java. And this is where we do the average. So we get the estimated diameter, we get the minimum diameter in meters, and we get the maximum. We divide it by 2. I just noticed this is quite redundant. We already do this check up here. So you can remove this line, you can remove this if check. It's not really needed, it's just redundant code. So let's go back up here. We have created a list of asteroid collision event. Now we want to send this on our Kafka topic. Let's check. So these have been created. If I do docker ps, these are running. The services we have defined are successfully running on our machine. We now need to send this on a Kafka topic. What we're going to do is the following. We need to define a Kafka template up here. We need to define key and the object we're going to be sending. And we need to add it to the constructor down here. Let's inject it into the constructor. And now for each event in the asteroid collision event list, we are going to put a message on our Kafka topic called asteroid alert. We are going to add some logging. So each asteroid is going to have its separate notification. So this is down to you how you want to design your service. I want to send a separate notification for each asteroid. You could put it all in one if you want. We have defined a Kafka template, but we need to define some properties in our application.properties. We need to let our Spring Boot application know where this Kafka is running. So it's running on port 9092. This is the name of our topic. So very important, this name needs to be the same as the one where you're putting your messages. We need to define a key serializer. So our key is a string and we need this string serializer. And our value, we want to be serialized as a JSON object. These are the 4 properties we are going to need. Now, if we go back to our service class, this is looking all good. Let's check our controller. The red is gone as well. We are almost ready to run our application. So just open your browser and let's go to localhost 8084. That's the UI URL. This is what you're going to see. We want to create a Kafka cluster. Just give it a name. I decided to call it localhost. And we want to give it a name, so I'm going to call it Kafka broker. Define on which port our broker is running. If you don't remember the port, just go back to your Docker Compose, and this is where the Kafka broker is running, port 2992. Let's validate, and this is all good. Let's submit, and this is created as a dashboard. So if you refresh your page, go on topics, we can see there is no topic for now. But this will be created automatically by our Spring Boot application. So we are now ready to run our application. Let's create a configuration. Call it Asteroid alerting. Let's select the main class. Click apply. OK. Let's run this. Application started successfully. We're now ready to send a post request to our service. The request will go to localhost port 8080/API/v1 asteroid-alerting/alert. Let's click send. So we got a 202 back as expected. If we go to our logs, we scroll down, we can see that we got 6 asteroids that are potentially hazardous. So we will be expecting 6 messages on our topic. If we go back to Kafka UI, let's update. And you can see we've got a new topic called Asteroid Alert. Let's go in here and we can see we've got 6 messages as expected. So each message is going to represent an asteroid. As you can see, we've got the asteroid name, the close approach date, the missed distance in kilometers, and the estimated diameter in meters. So we have completed the first part of our system. We have created this asteroid alerting service, which is querying the NASA API to get back a list of asteroids. And this list of asteroids has been filtered down and put on a Kafka topic as a list of events. We now need to build a notification service. That is the next step. We are now going to focus on building this notification service. So this is going to be another Spring Boot service that is going to be listening to the Kafka topic where we have put our asteroid events from the asteroid alerting service. We will get these events. We will save them in a SQL database. We will have a Spring Boot scheduled job that every few seconds will check this database to see if there are any unsent notification events. And if there are, it will pick up these events, collate them together in an email, and this email will be sent to a list of users that have subscribed to Asteroid notification events. So I will show you all of this in this section. The first thing we need to do is go to Spring Initializer and create a new Spring Boot project. It will be using Maven, Java. We will be using the latest Spring Boot version, and I'm going to call it Notification Service. And we will be using Java 21. We need few dependencies such as Lombok, Spring Web, and let's add MySQL driver, because we are going to be connected to a SQL instance as well. We're going to need JPA, and we will need Java Mail Sender. So this Java Mail Sender will be used to send emails to users. So once we have these dependencies, let's click Generate, and let's open this in IntelliJ. I have opened the project in IntelliJ. So the first thing we need to do now is create a new package called Service. And in this package, we're going to create a new class called notification service. And let's add a couple of tags. So this is a service class. And let's also add SLF4J for logging. So we have our messages on a Kafka topic. We need to listen to those messages. To do that, we are simply going to create a Kafka listener method. So let me show you how to do that. So let's call it public void alert event. And this is going to be getting an asteroid collision event, which is what we have built on the other service. This is going to be our Kafka listener method. So we need to add a tag called Kafka listener. We need to give the topic name. So our topic was called Asteroid alert. You can define a group ID. I'm going to call it notification service. So this is going to be the consumer group ID. And we're going to be listening to this topic. If you go back to Asteroid alerting service, we can see that these alerts are sent onto this topic. So we want the same name in our notification service. So we can see that this is red. If we go back to Asteroid alerting, we can see that what we put on this topic is an event object. And this event object is actually an asteroid collision event. We want to deserialize this in a notification service. We will recreate this class in notification service. So I'll just copy these entries. Go here at the top level and let's create a new package. So LeetJourney dot asteroid alerting dot event. As you can see, it will create a new package under com.LeetJourney, and in here we want to create our new class, asteroid collision event. In here, let's paste the attributes we have copied from the same class inside the asteroid alerting service, and let's add our tags. So these are Lombok tags that avoid us writing boilerplate code. Now, I just want to make sure that we are not going to be creating any new classes or packages under Asteroid alerting. So this is the only time we need to do that. Let's go back to our service class and let's import that. So the error is now gone. Notification. There was a typo. Let's also add some logging. So we know that an event has been pulled. So we have defined our Kafka listener, we have defined the topic. We are almost ready to listen to messages coming into our Kafka topic. We just need to go in the application.properties and we need to define some Kafka properties over here. So similar to what we defined in Asteroid alerting service, we need to define the group ID, in this case Asteroid alert. We want to define the deserializer, so we want a string deserializer and a JSON deserializer. And we want to add our trusted packages, which is where we have this asteroid collision event class. So this is all we need to listen to those messages. So let's also define the port where this application is going to be running. Port 8080 is already occupied by Asteroid alerting service. So this will be running on 8081. So let's go back to our notification service. So now that we have events coming inside our alert event Kafka listener, we want to take these events, transform them into an entity object and save them into our database. So let me show you our database schema. We will be having two tables, one called notification, which is going to have these attributes, and one is going to be called user. This is going to have 4 columns. As you can see, we've got notification enabled for each user. If a user has notification enabled, it means we want to send them alerting events. If it doesn't, we are not going to be sending any email to those users. In notification, we have an email sent column, and this is going to tell us if this asteroid has already been sent as a notification to our users. So we don't want to repeat sending these events multiple times. every time our scheduled job is supposed to run. It will be clearer in a bit once you see the code, but this is what we're going to be building. So let's go back to our notification service and let's create an entity package. We want to create this entity package in notification service. And we want to create a notification class. And we want to add a bunch of tags here, so it's important that we get these right. So this is going to be an entity, and we also need the table name. So we want this table to be called notification, and we will let our service handle the DDL of these tables. The next thing we want to do is create our attributes. We are going to be having an ID. We want the asteroid name, close approach date, missed distance. We also want the boolean to determine if an email has already been sent for this specific asteroid. We also need to create a new package, and this is going to be a repository package. And in here we want to create a notification repository interface. And we want to tag this as repository. And we want to extend JPA repository, and this is going to be a repository for our notification entity, and the ID is going to be a long. So this is what we need so far. The next thing we want to create is also the user entity. So let's just create it. We want the same tags as before. Only difference is that this is going to be representing a table named user. And we want few attributes, which are going to be our columns in the SQL. So we're going to have a full name, the email address, which is where we will be sending notifications, and whether notifications are enabled for this specific user. Let's also create a repository interface for the user. Let's tag it and let's extend JPA repository. This is going to be for a user class, and the ID is going to be long. So we have our entity classes, but we don't have a running SQL service in our Docker Compose. So what we need to do is go back to our Asteroid alerting and let's open our Docker Compose. In here, let's also add a new service called MySQL. We are going to be adding this MySQL service is going to be running SQL 8.3.0. Define the database name, so I decided to call it Asteroid Alerting. Define a port. We also want to define some volumes, so make sure these are added. We're also going to be needing this init.sql file to initialize our database. I will show you where to put this in a bit, and make sure to add the volumes here at the bottom. So our volume is going to be called DB data. You don't have to copy this. I will be putting a link to the GitHub repository where you can just copy and paste into your own project. But this is what you need. We need this init.sql file to initialize our database, and it has to be in this specific directory. So in your Asteroid alerting, go at the top level, create a new folder called Docker, and then create a new directory called MySQL. And then in that directory, you need a init.sql file, and you need to put these two lines. So we're going to create the database if it doesn't exist, and we'll call it Asteroid Alerting. And then we want to use this database for our operations. Now that we have added this new service in our Docker Compose, let's do Docker Compose -v app -d. And let's run this so that our SQL service gets created as well. So we can see that this has been successful, and our MySQL is running as well on port 3306. Let's go back to our notification service and let's go to the application.properties, and we need to add few properties to connect to our SQL service. So this is what you need. We need to define the name of the data source URL, and you need to make sure you've got the Asteroid Alerting database name here. Define the username and password. Yeah, they're probably going to be root and password. Define your data source driver class. Also, we want Hibernate to update our DDL put it as update. This will not delete your table each time you restart your application, but it will just restart it from where you left it off. If you want it to restart every time, you can put create. I will leave it as update for now. This is what we need to connect to our database. Let's now go back to our notification service and let's continue our flow. So we're going to be creating an entity for a notification we have received. Basically, we're going to be creating a notification object. Using the data inside the notification event, we're going to be populating this notification object. Make sure you put email sent as false, as this is just a new notification that came in and we want to set it as false. This flag is going to be important later in the flow. And now we want to save the notification inside our database. Let's use the notification repository and we're going to do save and flush. So this is red because we need to actually inject it into our notification service. So let's inject it here. Notification repository. Let's create a constructor and auto-wire it. So this is what we need. The error is gone. So we're going to be saving this notification we built using the data from the Kafka message. We will save it and then this will return as the save notification, and we want to print this save notification. So why do we want to print it after we save it? And that's because once this gets saved, we will get an ID assigned to this notification. As you can see, we don't set the ID because that's auto-generated, and it gets generated only once we add the data to the DB. So we do save and flush, we get back the object we have just saved, and we will print it down here. So far so good. So we have received our messages, we have saved them in the SQL DB. Now we want to be sending emails to users. So you might be wondering how we will be handling this email sending. So there are various services online that allow us to send emails. We will be using Mailtrap. So this is an email delivery platform that runs online. There are many that you can also run in a Docker container, but I just thought this is going to be easier. Mailtrap is an email delivery platform that is used to send emails to customers or clients or whoever you want. But we will be using the dev instance to do our testing. We don't want to be sending emails to real users when testing. So Mailtrap offers a testing service where it will simulate sending emails to users. So just go on Mailtrap, sign up, it's free. Once you have signed up, you need to go inside your dev environment. So it's going to be this one. So we're going to be testing emails on staging. There is a monthly limit, which is 100 in this case. We will be using SMTP, Simple Mail Transfer Protocol, to be sending these emails. Go inside your inbox, and once you are inside your inbox, you will be seeing an integration tab. We will need this information and we will need to put this in our application.properties. We will need the host, a port, we can choose any. I will be using 2525. You need your username and passwords. That's all we need from here. Let's go back to our notification.properties. And let's put all these properties inside our notification.properties. We need a spring.mail.host, we need a port, username, password, and we also need these other two properties, SMTP auth and SMTP *TLS.enable, to be able to connect to Mailtrap. And we also want to define another property. You can call it whatever you want. I decided to call it email.service.from.email. So this is the sender email you want to define. Now we have saved our notification events in the DB. What we want to do next is have a scheduled job that is going to be running, let's say, every 10 seconds. So let's use Springboot tags. Let's define a scheduled job that will run every 10 seconds. And let's call it public void send alerting email. Let's add a log so we know if this is getting triggered or not. And we want to create an email service and call a method in this email service. So this one does not exist. We are going to create one now. So let's go in the service package and let's create a new service called email service. Let's add the service tag. And let's also add some logging. So let's start with our logic. Let's create a public void method, which is going to be the send asteroid alert email. And we want to make this async. So let's remove this log. What we want to do now is create our email text. So let's create this string of text. This is because we have multiple Asteroid events coming inside our notification service. All of these will be saved into the DB as a single entry, and we don't want to be sending multiple emails. So let's say at a certain time we get 5 asteroids that we want to send notifications for. We will be sending them in a single email. Let's go back here. Let's create this text. I will be creating a private method to create this email text. Private string create email text. Check if there are any asteroids to send alerts for. So we are going to create a list of notification, call it notification list, and we're going to be using the notification repository find by email sent false. So as you can see, when I imported this notification repository, it injected it into our constructor, but we still have an error, and that's because this method does not exist. So let's create this method in the notification repository, and it's as simple as that. We're going to be using JPA magic. We will call it find by email sent. Email sent is the name of the column, and whatever is the value here, it will be matched, and we will get only notifications that have not been sent, so which have this email sent set to false. So if we go back, the error is gone. Now we want to check if notification list is empty. We are going to return null, and up here we want to handle the event where text is null. So if the text is null, we want to log it and say no asteroids to send alerts for, and let's add the time, and we're going to return. Otherwise, let's continue creating our email text. So I'll be using a string builder, and the first line is going to be asteroid alert. Let's add some separation. So email text dot append, and let's add some separation. And now for each notification in the list, so notification list dot for each, we want to print whatever is inside. Let's use Copilot's magic. For each notification, we're going to get the asteroid name, close approach date, estimated diameter in meters, and missed distance. And let's add some more separation. And once we've done that, we also want to make sure that this notification, we set the email sent to true. And let's set notification repository dot save, and let's save this notification so that we save this set to true. We could also put this after we have sent the actual email. Actually, it might be better to do it that way. For simplicity, I'm just going to be putting it here, but it's better if we actually do this operation after we have sent the actual email. So now we can return this email text. So it's a string builder, so we need to do toString. So we have built our email text. We have checked that is not null. If it's null, it means there are no asteroids that we need to send emails for. We need to now get the list of users where we want to send these emails to. Now let's get a list of emails. Let's use the user repository, and we're going to do find all emails and notifications enabled. We need to create this method inside our user repository, and let's also add the actual query. So select email, we just want the email from the user table where notification enabled is set to true. This will get back a list of emails, and we are now going to do a check also here. If to.emails is empty, let's log.info no users to send email to, and let's return. And now we want to send the actual emails. So for each email, we want to send an actual email. And after sending this email, let's add some logging and let's see how many users we've sent emails to. We need to create this send email method. So I will create it here. It's going to be a private void send email to email and the text. So we need to know where we need to send the email. Let's create a simple mail message. Let's call it message. And we need to set few attributes. So we need to set the email we're sending this to. We need to set a from email. So if you remember, in our application.properties, we have these attributes. So if you go to our email service, let's add it as a value up here. So let's use the value tag and let's have it in a string from email. So let's go back to our send email. Let's change this to from email. And now we want a subject. I will give it a name, NASA Asteroid Collision Event. Let's set the text. And now let's actually send this email. To send this email, we're going to be a Java mail sender. So we need to create this. If you go up here, let's create our Java mail sender. So private final Java mail sender. And we need to auto-wire it here. So let's also add the auto-wire tag. Let's add the Java mail sender. Let's inject it in the constructor. And the error is gone. Let's see what's happening. So every 10 seconds, this method is going to be called. We're going to try and create an email text. We will query the notification repository to see if there are any notifications that we need to alert for. If there are not, we'll return null and we'll stop. Otherwise, we'll continue and create the email text. Once we have the email text, we will get a list of users. We want to know if there are any users that have subscribed that want to receive these notifications. If there are not, we'll stop. But if there are, for each of these users, we are going to be sending a separate email. And we will build this email using a simple mail message object, and we'll use Java mail sender to send this. We have defined our SMTP server properties in our application.properties. This looks all good. Now that we have this, let's run our Asteroid alerting service. So let's start this up. Let's also create a configuration for our notification service. Let's select the main. Let's press OK. One thing I forgot is we need to enable scheduled jobs. So we need to enable scheduling. So you need to go in the class where there is the main method and you need to add the enable scheduling. Otherwise, this is not going to work. And we also need to inject this email service inside our notification service. I almost forgot. So let's inject that. Let's add it to our constructor. And the error is gone also here. Let's run the notification service. Let's connect to our database. I am going to be using MySQL Workbench. If you want more details in knowing how to connect to a database, you can check my other video where I build a full microservices system and I show this step more in detail. But for now, what you need to do is create a new SQL connection and connect to our database running on port 3306. Let's continue, and we can see that our database has been created, and we have two tables, notification and user. Our notification has some data, and that's because I already tested it. All of these have email sent already. This is okay. We won't be alerting on these anymore. For users, I have one user already here, but we need to add users, otherwise this is not going to work. And to add users, we can write a simple query. We can add some insert queries. So just you can look at these ones, you can copy and paste. But basically I'm going to be creating 3 users, 2 of which have notification enabled, and the last one have them disabled, just to show you something different. So let's run this and let's make sure they've been added. So we have 3 users, 2 of them have notifications enabled. We are almost ready to run this. Last thing I wanted to show you are the logs before we run this application. So you can see that every 10 seconds our method is actually running, but there are no asteroids to send alerts for. Let's call our asteroid alerting API and let's pull messages into our Kafka topic. So I've sent the request, it has been executed. So we've received events for asteroid collisions. We have triggered a scheduled job, and email has been sent to 2 users. And then 10 seconds have passed. It tried to trigger again, but there are no notifications to be sent. So if you go to Mailtrap, we can see we have 2 new events. You can see the emails that were sent to LeetJourney email, and the same one was sent to this other email. So this is a simulated email. So Mailtrap SMTP server interjects this email. It shows them up here. So these are simulated emails. And as you can see, this is the body of our email. If we go to our database and we query the notification table, we can see new notifications were added, and we have already sent emails for this one. Let's try again. Let's try to keep querying this so I can show you the email set to 0. So you can see these are set to 0. They have not been picked up yet, but if we run it again, 10 seconds have passed. Let's look at our logs. Email was sent again to 2 users. And if we go to Mailtrap, we've got 2 new emails. We have sent our notifications. You can see it wasn't too complicated. It was quite simple. So we have also built our notification service, and we have completed the small project we set out at the beginning. There are many improvements you can do to this system, such as adding Swagger docs. You can add prettier notifications. You can use Java Mail Sender and Mailtrap to send HTML emails that are going to look nicer. Or you can also go on and add better error handling to this whole system. This is up to you. You can be creative and use your imagination. I hope you found it useful. If you have any questions or if you're stuck anywhere, you can comment down in the box below and I'll try to help you out.